Hi everyone, thank you for joining this session and being interested in our PhD and Master by Research program in the Department of Architecture. My name is Eddie Lau. I'm currently the Deputy Head of Research in the department. Before we go with the presentation by Professor Woody regarding his research and study on the design for climate change, let me brief overview some research area and interest in our department. Some of you may come from architecture, but the rest may come from other professionals. You are welcome to join our research study program. I hope you agree with me that architecture is a multidisciplinary subject covering a wide spectrum of topics from art and social science to technology. It is hard to isolate the architect from different elements because architects is embedded into and integrated with building and built environment design. In our department, we currently divided 6 research clusters. They are all interrelated. The 6 clusters consist of history, theory and criticism, technology, urbanism, landscape study, research by design, and design education. The research cluster for history, theory, and criticism focus on architectural representation, colonial and post-colonial built environment, modern and post-modern architecture in Asia, heritage conservation, cultural heritage. We are particularly interested in the Asia and South Asia context and the tropical architecture. It is noted that our head of department holds dual chair on architectural heritage conservation and managed in Asia. He is a UECO chair on architectural heritage conservation and management in Asia. Another cluster is technology. It is the cluster that Professor Woody and I are coming from. Professor Woody is now the cluster leader. The research area include tropical technology, architectural and urban prototyping, urban climate design, urban analytics, design automation, and soundscape. Professor Woody and I are happy to share more with you. Under the technology cluster, we have some research lab. Urban climate design lab is led by our colleague Dr. Yun Chiu. He is one of our presidential young professors. Their research support climate-sensitive planning and design for sustainable and resilient city in real life. They are working on different research topics, including urban air quality, urban heat island, nature-based greenery, climate resilience, and urban aerodynamics. Another lab is the Urban Analytics Lab, led by Dr. Philip. He is another presidential young professor. The lab is advancing the frontiers of urban data management and analysis, geographical data science, and digital twin, with a strong influence by AI and crowdsourcing. I'm currently manage the NUS CDE Tropical Technology Lab. We focus on facade and green technology, including building integrated photovoltaic. We also focus on the co-location of energy and food production by building facade, building envelope. Another area we are interested in is the sonic environment. Similar to landscape, we are interested in studying the soundscape environment and how it impacts our life and health. The third research cluster is urbanism. They are interested in aging and healthcare, conservation and regeneration, community and participation, urban form and big data, resilient and informative. An example of aging and healthcare in this topic, we are particularly interested in high density urban environment for aging, design for health and well-being, long-term care and health supportive environments. Another example of urbanism is conservation and regeneration. The area of interest includes urban history and morphology of Asian city, urban and rural regeneration in Asia, heritage conservation, and heritage management. If you want to understand the research interests of our colleagues, you are welcome to oppose them or review their publication. Here's one of the books published by our colleague recently in urbanism. Without further ado, I may not spend too much time explaining the other area of urbanism. Here we release another free topic, the urbanism colleague they are interested. The research cluster for landscape study covered different scale and ecological social spectrum. Furthermore, the research cluster for research by design developed transitional research approach through creative practice. Last but not least, the research cluster for education provides faculty for architecture, landscape architecture, and architectural conservation with a platform and forum to advance discourse, research, scholarship, and best practice in design education. This is one of the posters showing our study of how instructional visualization impacting on learning in different architecture students. That was only beginning. It is my pleasure to introduce my colleague, Professor Rudy, who is our Assistant Dean of Research in CDE. He will share with us the topic of design for climate change. Professor Rudy, the floor is yours.
Thank you very much, Eddie. It's a pleasure for me to talk about this topic, and I will share my screen. I will be talking about a number of research projects relating to design for climate change. Obviously, this is not exhaustive in any way in terms of research that is being done within the department in design for climate change, but I hope that it gives the audience an interesting view of the kind of research that is being done. And I would start with a project that is actually not at all about research. This is one of the buildings of what used to be called the School for Design and Environment. The building is shared by architecture, built environment, and industrial design. And this building that was opened in early 2019 was Singapore's first newly built net zero energy building. So this was very important for the department to show, of course, that its knowledge and expertise can be applied within its own buildings. But at the same time, it can be noted that a lot of the solutions, the non-technical solutions, are not necessarily all that new, like the large overhanging roof, the shaded facades, the porous spaces, etc., are of course solutions that have been around for a long time. And these are complemented with some high technological solutions, such as solar photovoltaic panels on the roof and an innovative hybrid cooling system. And here you can actually see a picture of the building. What is interesting to note about the hybrid cooling system is that it cools the air to a temperature that is much higher than what would normally be found in a air-conditioned building. So this obviously reduces less energy. It does mean that the temperature inside is slightly higher than one would expect. But by adding ceiling fans everywhere, there's a stream of air that actually provides a comfort to the people inside without having to produce the same cold temperature. A side effect of this is that the building relies entirely on fresh air being circulated. So there's no recirculation of air going on. And this, of course, doesn't lead just to a sustainable building in terms of energy use, but also results in a building that is healthy for its users. And we, of course, got confronted with that very much during the pandemic, when recirculated air could be dangerous because they could have virus in it, whereas fresh air generally would be much safer. And so this building was the first educational building in the world to get the gold medal by the Well Building Standard. So this is the Well Building Institute, the International Well Building Institute, an added benefit. Actually, I mean, it's not a surprise, of course, but it's an added benefit of the sustainability. And here are some images of interior and exterior buildings. And of course, one can comment that such things are easier to achieve in a new building. But in the meantime, we are also renovating. We have completed SD1 building. SD3 building is almost completed. And we hope to achieve, we are applying the same technologies and we are hoping to achieve the same results. In fact, SD4 now got a Green Mark award from the Building and Construction Authority for being net positive energy. So it actually is producing more energy than it is using. We'll have to see what happens to SD1 and SD3, but for sure, the whole site and with the extension, the whole campus of NUS should in the future be net zero energy. So an important part, of course, of dealing with design for climate change is looking at energy performance and the prediction thereof at the building scale, as what was done for SD4 and etc. Now, there are two main ways to go about this. The most, let's say, default way, the most used way is to do simulation. Simulation can be very accurate. There is lots of software available to do so. The downside of simulation is that it needs extensive knowledge on the building system, on the mechanisms that occur both inside and outside the building geometry. And this relies on information that is generally not available in the beginning of the design phase. It's only available when the building has been fully elaborated and we know how it will be operated, etc. And then we can do very accurate simulations. But at that time, there is usually little to change about the building because all the things have kind of already been decided. Another approach is to use statistics, data mining, artificial intelligence, and there are, again, a number of approaches to do so. The downside of this is that it requires a large amount of learning data and a mainly relevant and complete database. So in this particular research project, which was the PhD of a PhD student in architecture, Yezong, he combined the two in order to be able to do a much earlier energy performance prediction at the building scale. And we looked especially at residential buildings and more specifically to Singapore's public housing stock, because 80% of Singapore population lives in these public housing stock that is developed and maintained by the Singapore Housing and Development Board. And on the left-hand side, you can see a map of all the HDB housing estates in Singapore. So all the blue are estates. And on the right-hand side, you can see the energy use of these buildings. And this data comes from the Energy Market Authority. And so obviously not all these buildings were all built at the same time. They are not all at the same height. There are other values that differ between them. So this kind of information Yezong used to predict the energy performance prediction of housing. And for that, so as I said, he combined the two approaches. On the one hand, he created a baseline HDB building, kind of like a standard HDB building, and did a very complete energy simulation of that in order to determine its energy usage intensity. So that is the amount of energy it uses per surface area, so per square meter, for example, and compared that through a neural network with the real consumption data that we got from the Energy Market Authority. And obviously, he looked at a number of parameters that seemed important from literature, including the number of stories of a building, the green plot ratio, the floor area ratio, the sky view factor, the gross floor area, and the building capacity. And so this neural network was then, comparing these data and trying to figure out how this real consumption data relates to these 6 parameters. And the result was that 3 parameters stood out as being more important, much more important than the others. And the first one is the number of stories. The higher the building, the lower actually the energy uses intensity. So obviously the building itself may use more energy, but per square meter, the energy use is lower for higher buildings. And that is usually the case because at a higher level, natural ventilation can be used more easily. There is more wind available than at the lower levels. And the same can be said about the gross floor area. Now, obviously, there is some relationship between the gross floor area and the number of stories. But you can clearly see in the diagrams how the relationship is between energy usage intensity and GFA or number of stories. And the last one is the building capacity. So in another project, we're extending this to the urban scale, looking at how can we do the same energy performance prediction at the larger urban scale. Obviously, we cannot use the same level of detail using detailed simulation at the urban scale because it would take way too long. We're doing this with obviously we're not doing it at this moment at the entire Singapore scale. So we're using actually the university NUS as a case study. We have a building cooling load information for some of the buildings. And we use that data to basically, we have a software called City Energy Analyst. That is a software that was available that we are using. And we improved its parameters based on the building data, the cooling data that we had available, and then extended it, of course, to the entire site. And then we are looking at different scenarios. So one of the things that is important is to know where this building is located. I mean, in general, you'd use a weather file for a particular area. And the Singapore weather file is related to a weather station at Changi Airport. But here in this, and this is a study from Yuan Shao's group, in which he looked at mapping the anthropogenic heat impacts in residential areas, which is basically the urban heat island phenomenon. And you can see that there's some areas where the temperature is much higher than in other areas. I mean, much higher. It can be up to half a degree or more. And this, of course, plays an important role. So this data we're using as input to our simulation, and then we're looking at various scenarios. For example, climate change. If the temperature increases over the time in the next years, or maybe a heat wave where it's a very localized in time, where it can be very hot, or such aspects as work from home, which became very important with the pandemic. Then, of course, the energy use for the city completely changes because everybody is working from home and may need air conditioning to be able to work there. And all these office buildings are half empty or even more. And we're looking at other things, possibly like haze, although Singapore fortunately hasn't had to deal with that too much recently. But so we compare different aspects of, let's say, half of the people who are working from home in a particular year, depending on climate change, etc., to see what the energy use would be accordingly. And then we're trying to combine this with, so not just looking at the building itself, but looking at the choices that people make. So we can figure out how many people there are in a building at a particular time based on campus Wi-Fi data. We can also collect thermal comfort data of people for certain locations. And to take it, we can bring all this information together in an agent-based modeling in order to study the effects of activity location choices on occupant well-being and energy demand. So whether people are all working at the same time in the same area, or other choices. And again, of course, to do this at a larger scale, we have to make some assumptions. So we create a series of standard, let's say, or normal situations that can occur, such as being at home, studying, having a meal, leisure, etc. And what we're also trying to see is to look at what would be the impact of electric vehicles, so future electric vehicles, on energy demand. So obviously, electric vehicles will increase the energy demand, especially focused on electricity. But at the same time, by manipulating when these electric vehicles are being loaded and what happens with the energy that is stored in the batteries, we can actually try to reduce the peaks of energy use throughout the day. And so for that, we need to know the demand side flexibility from residential blocks and the car parks next to it that host EV electric vehicles. And then we can build a model to simulate flexible distribution grids in both a high spatial and temporal resolution. So all this to be able to figure out what is, how we can reduce the operational energy, because of course, the more energy we use, the more carbon that is being produced, and carbon adds to climate change. But it's not the only thing that adds to climate change. We shouldn't just look at operational energy, we should also look at embodied energy, the energy that is needed to create a building, to create the materials, etc., that go into a building. And for that, to reduce that energy, we can, of course, use different materials that have a lower embodied energy, but we can also focus on reusing building components and building materials, so actually applying circular economy to construction. And for that, we need to understand and support the emergence of sustainable material flows within the city or a particular area. So there's basically a huge amount of annual construction waste that has to be dealt with. We just cannot go on like this. So then the question is, what is possible? What can be done? And we need to look at all aspects of the circular economy, from design to manufacturing, maintenance, reuse, recycling, to reduce the use of raw materials and to reduce the residual waste. And of course, we're applying this in this project to Singapore as well as to Zurich, because we're collaborating with people from ETH Zurich, and looking both at the existing building stock and at new buildings. So in terms of the existing building stock, we're trying to understand how much material basically is available and what kinds of materials are available in these buildings, so that we can get a better understanding of what might be able to be reused over time when it becomes available, etc. And for that, we can use AI techniques such as unsupervised clustering in order to identify building archetypes. Now, we cannot do this necessarily for each building individually because we don't have enough information, but for building archetypes such as the public housing, public residential buildings in Singapore and other types of buildings, we could do so. And then, of course, we also need to look at new building design. So how can we change the design process and allow designers to use information about materials that are available or may become available by the time the building gets constructed in the neighborhood, preferably, of course, so that we don't have to move materials around too far, and store all this information This, of course, requires a lot of information, and this has to be stored and as a material passport of buildings. And all this kind of comes together in climate planning. So basically, this is another project in which we're basically trying to focus on, okay, how can we plan for Singapore for the future in order to mitigate climate change? Firstly, through decarbonization. So how can we reduce the amount of carbon used, so the embodied energy, the operational energy, but maybe also how can we capture carbon in the urban environment? And related to that is to mitigate the effects of sea level rise and flooding, whether this is coastal flooding or fluvial flooding from the rain. How can we redesign the environment so that flooding doesn't become a problem, right? Right now, if it gets flooded and then we can't get through, and it's a big problem. So how can we mitigate those issues for Singapore? And we're focusing on the coastal area around Singapore between the Changi Airport and Tuas Industrial Estate, so a large area. And we're basically using scenario planning. So the idea is to using studios and other, maybe a competition, etc., to develop and generate potential urban planning and design scenarios at various scales, from the district, the neighborhood, the estate, and the building scale, and to learn from that what the possibilities are to do this in a computational way so that this information can be collected and analyzed, and from that learn what would be best practices. And I will close my presentation with that, and thank you very much for your attention. And thank you, Eddie. Back to you.
Okay, thank you, Professor Rudy. Yeah, we may have some time to take some questions. If the floor you have, please feel free to unmute your mic or type your question on the chat, so that probably maybe we can answer your question if you are interested in our research study program. Before we go with the respond to your question, probably I just would like, because PhD program is quite a particular program, is on your own way, kind of on your own way, on what your own topic. So at the end of my presentation, in fact, please feel free to contact with our professor if you are particularly interested in any topic, that we can discuss the idea or what the opportunity we have and support we have for your study. Maybe and also please feel also contact me if you have any question about the PhD and master program by research. I'm very happy to respond your question, and also I can also direct you to some of our colleagues if there's some of the topic specific question. Yeah. Is there any question from before? So if not, I also want to mention that in fact we have a 2 intake in each year because we are 2 semester system. We have August intake and also January intake. The January intake is the deadline is very close by the end of this week, if I'm correct. But for the August intake, we will maybe a little bit later. Please check with our website for the exact date of the deadline for different group of the applicant. And also you can check our website. There's a kind of our graduate school website. They also have a lot of information regarding the scholarship and financial assistance and tuition fee. You can check with our school graduate school website.
Excuse me, may I ask a question?
Yes.
Thank you. My friend want to join this report, but he is have no time. So my question is, will this report be replayed? Thank you.
You mean share with I'm not sure we will share the recording. Kahin, you are here. Do you know that whether we will share the recording?
Yes. Hi, Andy. What we'll do is after this, it might take us some effort to do the necessary edits. So some part of it we will share on social media.
Oh, thank you very much. Thank you.
Thank you.
Thank you, Kahin. Kahin is our vice dean for the graduate program.
Thank you.
Yeah. Any other further question?
If there's no other questions, I think we can end early. It's
Yeah.
6:34 now. Yeah.
Okay. Maybe we end this session. Please, if you are interested in our other program, in fact, we have another day tomorrow. We have another session to introduce our other program. Please come back tomorrow if you're interested in other program. Thank you very much. Thank you for joining this session. I wish you all a good evening. Thank you. Bye-bye.
Thank you.